Welcome to Chapter 4C for Math 113, Savings Plan and Investments. This is the third section in Chapter 4. The first one, 4A, dealt with budgeting, if you remember, and the need for a budget to control our money. And 4B dealt with types of interest, a simple and compound interest in a savings account. Chapter C is a savings plan. Now we learn a new formula called the savings plan formula. Note that it's a little bit longer and harder. Each one gets a little bit tougher. It's just a matter of taking it very slowly, and then you will get the right answer. Let's go through our parts here. What is A? A is the accumulated savings plan balance, what we will have after so much time if we put in so much each month at a certain interest rate. Payment is the amount that we're going to deposit each month. APR is your annual percentage rate, which is given as a percent, which you then take and change to a decimal by get rid of the percent and moving the decimal to the left 2. N is your number of payment periods per year. Notice that it's always per year in the formula. So if you're given a time factor that is in months, you cannot write the months down. You have to put the months over the year in a fraction. And our first example will show you that. And then Y equals the number of years that you will be, Y is the number of years that you have to watch for being always in years. So A is also called the future value. P is also called the present value. We're not going to worry about that at this point. Those are just other names you might hear it referred to as. Now we're going to look at, first of all, the first problem, which says, use the savings plan formula to calculate the balance after 6 months for an APR of 12% and monthly payments of $100. So we're saying we're going to put in monthly payments. Every month we're putting in $100 to a savings account. And in 6 months, I want to know what my balance will be if I get 12% percentage rate. So to figure out what you'll have, you can use this formula. Now you could do it by hand and just add each month up, but it's a long drawn out process. This formula will tell us right now what I'll have, in 6 months if I do this. So first let's list what we have. Use the savings plan formula, so that tells you to use this formula up here, to calculate the balance after 6 months. So this is going to be key. APR of 12% and a monthly payment of $100. So there's 4 bits of information here. There's monthly, there's a deposit of $100, there's 6 months time period, and there's an APR of 12%. So let's list them using our letters. PMT is equal to our monthly payment, which is $100. APR is our annual percentage rate, which is 12%, and we change that to 0.12. N is our number of times it's compounded, and that would be monthly, so N is 12. Anytime you see monthly, it's 12. And then our Y should be in years. For how long are we doing this? And note that we have 6 months. Well, that means you have to list this as 6 months over 12 months because it's not a whole year. It's the fraction of a year. Now, you know that's 0.5. But this is what you would do. If it was 9 months, you'd put 9 over 12. But it's 6 months, so we put 6 over 12, which is 0.5. Now we just fill into our formula up above. So we have A equals, the first part, payment, is by itself. So that is the $100. Times, then we have this big long fraction. And in the fraction, we have a 1 plus APR over N. That would be 0.12 over 12 raised to the N times Y. That would be N is 12 times 0.5 minus 1 over 0.12 over 12. And this is going to give us if you go one step at a time, you'll be okay. Some people are able to put it right into their calculator and get it in one answer. Sometimes it's not that easy. If you want to move a little slower, what you're going to want to do is to do what's inside. Let's change our color here. Do what's inside first. So let's figure out what this is. Now, hopefully it comes out even, because if it doesn't, it creates a bit of a problem because we have to use fractions. So let's just do that. 100 times, up here we're going to have 1 plus 0.12 divided by 12 will give you 0.01. And this is going to be raised to the 12, that is a 12, times 0.5, and 12 times 0.5 is 1/2 of 12, which is to the 6th power minus 1, all over, remember 0.12 divided by 12 was 0.01. So now we have A equals 100 times, in here we're going to have 1.01 to the 6th power minus 1 over 0.01. Keep going. We're going to work from the inside out. So we have 1.01 to the 6th power. 1.01 raised to the 6th power. Using your calculator, you're going to get 1.061520151 minus 1, whoops, parentheses, all over 0.01. So now A equals 100 times, again, we're still working on this part of the problem. So take that amount minus the 1 and then divide by the 0.01, and you're going to get 6.152,015,06 times 100 will give you A equals $615.20, round to the nearest hundred because we're dealing with money. So let's review what we just figured out. If we deposit $100 every month with an APR of 12%, in 6 months we will have in our account $615.20, which makes sense because monthly payments of $100 in 6 months would give us the $600, and then obviously our interest is the 15.20 from the bank. That's our 12% interest. So note that we're not doing it out each month and adding it. We're just saying, hey, how much would I have if I do this for a year or 6 months? And we get a final. This tells us if we want to go this route or not. Okay, let's see if we have time to look at another one. We do. Your outline says, let's look at page 241, number 15. Excuse me. So 241, number 15, and to do that, I'm going to have to erase what we have. So hopefully you have this written down so that we can use this space for other information. Okay. In our book for this problem, we have given on page 241, number 15, it says, and I will read it to you so that you have it. 241, number 15, it says, assume monthly deposits and monthly compounding for the following savings plans. Find the savings plan balance after 12 months with an APR of 3% and monthly payments of $75. So let's write down what we have. Our payment is $75 each month. Our APR from the book is 3%, which equals, go to 0.03. Our N is 12 because it says monthly, and our Y says 1 year. So let's substitute into our formula. We would have A equals, notice the 75 is by itself, and then we have a fraction. 75 is not part of the fraction. And in here we have 1 plus 0.03 over 12 raised to the 12 times 1 minus 1 all over 0.03 divided by 12. A is going to equal 75 times, if you work this out, see if you can stop this tape and see if you can, or stop this recording and see if you can get this amount, 0.3041595691 all over this amount, which is 0.0025. And let's work that out, and we would get 75. A equals 75 times this works out to 12.1663827. RA then, final answer is $912.48. That is how much money you would have at the end of 1 year if you're depositing $75 a month at 3% annual interest. You will have $912.48. Okay, now if you continue on here with our problems in the outline, you'll see some different wording, but it's done these problems are done the same way. At age 30, Michelle starts an IRA to save for retirement by depositing $100 at the end of each month. If she can count on an APR of 6%, how much will she have when she retires 35 years later at age 65? The trick here is the years. So you start with the amount, the payment, and I'm going to just get you started on these, equals $100. The APR equals 6% equals 0.06. The N is equal to 12 because it is each month. And then our Y is equal to, we have to figure out our years. So she retires, she wants to know how much she'll have when she retires 35 years later. So N is going to be 35 years. Or Y, sorry, Y. So I want you to use the savings plan formula and work that out, and I'll give you your final answer here so you can see if you get it. Your final answer is $142,471.03. Then the book refers you to page 241, number 19. 241, number 19 says, at age 25, you set up an IRA with an APR of 5%. At the end of each month, you deposit $150 in the account. How much will the IRA contain when you retire at age 65? Compare that amount to the total deposits made over the time period. Excuse me. Okay, this one's a little bit more difficult, and we won't have time on this video to do this one. So I'm going to stop the video here, and I'll continue this with you on the next video.